Alright, so we're going to take a look at inverse functions. Now, an inverse is what it sounds like it is. It's something that does the opposite of what the original process was. Let's take a look at an example. Let's say we had, let's say this is an XY table. Okay? And if we plug in 2, we get, if we plug in 2, we'll get 9. If we plug in negative 3, we get negative 1. If we plug in 0, we get 5. Alright? Now, its inverse function would do the opposite. If you plug in 9, you would get 2. If you plug in negative 1, you would get negative 3. If you plug in 5, you would get 0. Alright, so they're opposites. So what function is this? To get from here to here is actually the function 2x plus 5. It's a linear function. So how do we go back? Starting with this number, well, to get from here to here, we doubled and then added 5. So to do the opposite, we would subtract 5. Well, we'd start with our number, we'd subtract 5, and then instead of doubling, we'd halve. So these are inverse functions of one another. That actually simplifies to be 1/2 x minus 2.5. Alright, so these are inverse functions of one another. And this is a method for finding the inverse of a function. If you know that y is equal to, well, let's not use y, let's use f of x. If we know f of x is equal to 2x plus 5, to find its inverse, you want to have a value, knowing the value you get, this would become our x value in the inverse function, and this would become our y value in the inverse function. Okay, so this would become 2 times f of x inverse. Alright, so this becomes the inverse, and this becomes x. Now by solving for f of x inverse, we get the inverse function. Alright, so we'll subtract 5 from both sides. Yeah, subtract 5 from both sides. And divide both sides by 2, and we get 1/2 of x minus 2.5 equals f of x inverse. Okay? So that's how to find the inverse function. So let's say we were given a slightly more complicated inverse function. Say we had y is equal to, I don't know, x squared. Find the inverse function. This would become f of x inverse, and this would become x. So to get f of x inverse by itself, we take the square root of both sides, and we get plus and minus the square root of x is equal to f inverse. This is not a function, so that means that this function was not invertible, because this is not a function. So some functions are not invertible. So let's take a look at these two functions. We take this graph, we move it to the front, so it's not being blocked by anything. So we have the original function. I'm going to actually make the inverse function entirely blue so that it's different. Everything blue, blue, text, lines, everything blue. Ooh, not the fill. I didn't want the fill to be blue. Okay. So, let's take a look at the original function, f of x. Starting at 5, it goes up 2 over 1, so it's this line. And the blue line we're going to have now starts at negative 2.5 and goes up 1 over 2. Up 1 over 2. So it looks like that. Okay, so these functions have a pattern between them. Any function has inverse function. And they appear to be similar. And that's because they will be a reflection across this line here. Oops. It'll be a reflection across the line y is equal to x. Okay. So knowing that, if you knew one function, you can find its inverse by simply mirroring it across off this line, over this line. You'd find the inverse function. Alright, so these are both functions. So let's take a look at the example I mentioned before that was not invertible, and why it's not invertible. So we have some other function, also f of x, and it will be f of x equals x squared. So that's here. So that's the graph of f of x, which means its inverse should look something like this, a reflection across that line. And this top part is this, and the bottom part is equal to the negative square root of x. So the reason this is not an invertible function is it's not a function. It fails the vertical line test, but this is what the inverse of this function would be. Alright, so if I made up any other function, we should be able to find its inverse by just graphing it. So let's do that now. Any function in the world. So let's say I had the function f of x is equal to the square root of x. Well, that's this function. Okay, its inverse should be this, and that's the function f inverse, which is equal to x squared, where x is greater than or equal to 0. Alright. Alright, so inverses reflect across the y-axis. Also interesting, if you take the composition of a function as inverse, so let's say we took these two functions from earlier, and we took their composition, so f of g of x, you should get, I forget what you get, I think you get 1 when you take their inverse. Alright, so that would be f of, it's not f, sorry. So the f of f inverse of x should be equal to x, and let's check that. So if you plug 1 in, you get this line. Okay, the inverted line, the mirror line. So that would be f of 1/2 x minus 2.5. So that's f well, not f of 2 times 1/2 x minus 2.5 plus 5. I don't know why I put that parenthesis there. So that's x minus 5 plus 5, x equals, well, we just get x. Okay, so if two functions are inverses, if you take their composition, you'll get x. So, what's the important part of this to practice? The important part of this to practice, I would say, is finding the inverse of a function knowing the function. So let's erase all of these and make up a new function. Alright, so let's say we had f of, let's see, x is equal to 3 to the 2x power. Not even. That's not a good function for this. F of x is equal to 3x minus 5. Alright, to find the inverse, we make this f of x inverse and this into x, because they're going to send each other to each other. So the values we plug in for here should bring us to this. Okay, so to simplify that, it's x plus 5. Alright, divide both sides by 3. That's the inverse function of this, and if you graph them, this one looks something like this, the other one would look something like this. We can simplify that to uh, 1 over 3x plus 5/3. Should be up here, and this would be going up slightly. Alright, so I hope that's all we need for that.